Hey makers, welcome back to Hub360 Embedded Sphere, your favorite stop for building real-world IoT and embedded projects. In this tutorial, we'll be building a smart irrigation system powered by two 3.7 volts Lion batteries and a buck converter. The system automatically turns on the water pump when the soil is dry and turns it off when the soil is wet, saving you the stress of manual watering. Components used: we used a one Arduino Uno, one soil moisture sensor, one relay module 5 volts, a DC water pump, two 3.7 volts Lion batteries connected in series, one buck converter, jumper wires, breadboard, a mini breadboard. Get all components at www.hub360.com.ng. We will start with the power supply. Connect the battery and the buck converter. Connect two 3.7 volts Lion batteries in series with the aid of a battery holder. This gives 7.4 volts. Connect battery pack positive to buck converter V in positive. Connect battery negative to buck converter V in negative. Adjust the buck converter to 5 volt output with a multimeter. Connect buck V out to Arduino V in pin. Connect buck V out negative, that's the ground, to Arduino ground. Now move to soil moisture sensor connecting to Arduino. Connect the sensor VCC to Arduino 5 volts. Connect the sensor ground to Arduino ground. Connect the sensor analog out to Arduino A0. Now move to connecting the relay module to the Arduino. First, we connect the relay in to Arduino D8 pin. Now we connect the relay VCC to Arduino 5 volts. Now we connect this relay ground to Arduino ground. We'll move on to connecting the relay to the pump wire. Connect the relay COM to 5 volts from buck converter V out positive. First, connect the relay common to buck converter V out positive. Connect the relay normally open to pump positive. Connect the pump negative to buck and Arduino ground. Now for the code explanation. This defines the sensor input and relay control pin. This represents sensor extremes. Dry value when the sensor is in air, wet value when in water. They are used to calculate soil moisture percentage. Pump turns on when moisture is less than 30%. Pump turns off when moisture is greater than or equal to 70%. Pump always runs for at least 5 seconds to avoid rapid toggling. For the setup function, this starts the serial monitor. This initializes the pins, and this ensures pump turns up at startup. For the loop function, this reads moisture every 1 second. This converts raw reading percent moisture using map to percent function. If soil is dry, that's less than 30%, the pump turns on. If soil is wet, that's less than or equal to 70%, and minimum runtime is passed, the pump turns off. This function converts raw analog values into 0 to 100% based on calibration. The set relay function. This handles whether your relay mode is active, low or high. Upload the sketch to Arduino using IDE. Open serial monitor at 115200 board to see readings. Insert the sensor into dry soil. The pump should turn on. The pump pumps water until the soil is moist. The pump should turn off after minimum runtime. Adjust calibration values if readings doesn't match reality. In this project, you have learned how to use a soil moisture sensor with Arduino Nano, control a pump via a relay with hysteresis logic, power the entire system safely using Lion plus buck converter. All components are available on hub360.com.ng. Like this video if it helped, subscribe so you don't miss the next tutorial. Until next time, keep building, keep innovating. This is Hub360 Embedded Sphere, helping you bring your ideas to life.